All right, welcome back. So today we're going to be looking at our next lesson, which is concentration of ions. So this is building off of the concentration stuff from the last lesson. And it also ties in with the stuff we did last week with dissociation equations. So of course, as we know, solutions with ionic compounds and strong acids are able to conduct electricity because they have ions or they are electrolytes. Now this is because of their dissociation or ionization equations. So when we have molar concentration of ions in solution, it's going to depend on the number of ions making up the compound, or from its dissociation equation. So of course our first step when we are looking at trying to figure out concentration of ions, we need to write out a dissociation equation to find the coefficients, essentially trying to find out how many ions there are. So for example, when we look at like sodium phosphate, this, of course, is aqueous, so when it breaks apart, we know it's going to break apart into the sodium ion and the phosphate ion. Of course, when we balance it, we can tell from our balanced chemical equation there's 3 sodiums and 1 phosphate. Right, so these are all the molar coefficients in front of our sodium phosphate, or this would be the balanced dissociation equation associated with sodium phosphate. Now, of course, calcium chloride can also dissociate, and when this dissociates, it's going to form the calcium ion, which is Ca2+, and the chloride ion, Cl-. Now, of course, we write out the ions first, then we balance second. So we can tell that there's 1 calcium, so I can just keep a 1 in front of there or leave it blank if I want to. There's 2 chlorines, so we stick a 2 in front there. All right, so that's just a little refresher on our dissociation or ionization equations. So when we were trying to figure out the concentration of particular ions, the reason why we went over this a little bit right here is our first step is we need to write out the balanced dissociation or ionization equation. So once we get this, we're going to use a conversion factor to change between chemical units in a balanced chemical equation. So this is called the molar ratio, or it's just a conversion factor. For now, we're going to call it the mole ratio. So this is exactly the same procedure that we've done for law of combining volumes in the gas unit, where you have a balanced chemical equation, like so, and we're going to use molar coefficients in order to change between units of, let's say, calcium chloride to the calcium ion, or the chloride ion to the calcium ion, and so on. So we've done the exact same thing. Now, note what you're going to notice here as well is that sometimes you're going to see square brackets around ions. So it's going to look like this, and the square brackets is just for concentrations. It's a shorthand that chemists use. So instead of writing out concentration every single time, we'll see what is the concentration of aluminum ions. So that's how we're going to represent concentration of aluminum ions right here, and sulfate ions in a 0.4 moles per liter solution of aluminum sulfate. All right, so first step, as we said, we need to write out the balanced dissociation or ionization equation. So we have aluminum sulfate right here, and it's asking for what is the concentration of the ions. So my first step, balanced dissociation equation. And we know it's aqueous, so we can write Al2SO4 3. Then of course we got this from the drop and swap, and it's going to dissociate. So it's going to dissociate into aluminum ions, which is Al3+. And of course, if you're not sure how to find the charge on the ions, go to your periodic table, and we'll see aluminum right here, and it has a charge of 3+. And of course, our sulfate, we're going to get up here, and the table in our periodic table, and sulfate is SO4 2-, which is right here. I know it's going to be hard to see, but hopefully you can see it with your periodic table a little clearer. We get SO4 2- AQ. Now, after we write out our unbalanced equation, now we balance, right? So we look at our reactant, so we see Al2, so that means that there's 2 aluminums. So I'm going to stick a 2 in front here. Then finally, our sulfate, we have 3 sulfates, so I stick a 3 in front there. And that's what we have. So that's first step. Boom. Second step, use the conversion factor to change between chemical units or change between concentration units. So what we have right here is we have 0.40 moles per liter. Now this is only going to work for concentrations. All right, so if we're given a mass, we're going to need to find concentration first. And that's why it's concentration of ions. So our given, right, we have 0.40 moles per liter. Now, sorry, I'm just going to write this a little differently just so that liter is really noticeably in the denominator. Moles per liter of Al2SO4, 3. Now we're going to multiply this by a conversion factor. Now, depending on what we're trying to solve. Now, in this case right here, let's solve for aluminum first. And this is what we're doing. So that means we want aluminum, and on top part of our conversion factor, the thing we want is always in the top, and the thing we want to cancel out is going to be, well, the thing that we start off with, aluminum sulfate. We don't want this anymore. So this is how we cancel our units. Now, as for the numbers, they come from our balanced chemical equation. So the number attached to aluminum is 2. So 2 aluminum. The number attached to our aluminum sulfate, it's not written there, but it's always a 1 if it's blank, so we have 1. So how this works, we'll notice that aluminum sulfate, numerator, aluminum sulfate, denominator. So those units cancel out. What we're left with now is 0.80 moles per liter of, and now we have Al3+. And that is how we get the concentration of the aluminum ion. Now, I don't have enough room here, or do I? No, I can't scroll down anymore, so I don't really have enough room to get to sulfate. So just pause this video if you need to and finish copy that down, because I'm just going to erase this and write it the sulfate one. Alright, so now for our sulfate. We're going to do the exact same thing. So we're going to start off with our 0.40 moles per liter of aluminum sulfate, Al2SO4, 3. We are going to do a conversion factor. Now this time we want sulfate, and we want to get rid of our aluminum sulfate. Now the numbers that we choose, same thing. The number that's in front of sulfate is 3. So the number in front of sulfate is going to go 3. The number in front of aluminum sulfate is 1. Now by dimensional analysis, we'll see the units of aluminum sulfate are going to get canceled out. And then what we're left with is 1.2 moles per liter of, in this case, SO4. Sorry, I can make that look a little nicer. And then we got SO4 2 minus. And of course, 2 significant digits, and that is our answer. Now, just a reminder, we can only do this concentration of ion step if we have concentration. So our next examples, we're not going to have concentration initially. We're going to be having a mass, but then we can solve for concentration, all that stuff. But you had to remember that this is the conversion factor that we need to pull off in order to solve for it. So example 2 on the next page says calculate the molar concentration of the cation and the anion when 25 grams of magnesium chloride solid is dissolved in 100 milliliters of water. So I'm just going to have my dissociation equation written first, and then I'm going to solve for concentration. All right. So we have magnesium chloride. So remember, in order to get correct chemical formulas, we have to do the drop and swap. Right. So magnesium is right here, and magnesium has a 2+ charge. Chlorine or chloride is right here and is a 1- charge. So the correct chemical formula, Mg2+, chlorine 1-. So remember our drop and swap, the 2 is going to drop, go in front of chlorine, the 1 is going to drop, go in front of magnesium. So our chemical formula is MgCl2. So when this gets put in water, it's going to dissociate. We're going to reform the magnesium ion, so Mg2+, and we are going to form the chloride ion, Cl-. And of course, now we need to balance, so we have 1 magnesium, we're good. Chlorine, we got Cl2, there's 2 chlorines, so we have 2 here. All right, so mass is given 25 grams. Now molar mass obviously isn't given, but we can go back to our periodic table. We have 1 magnesium and 2 chlorines, right? So we add 1 magnesium, the molar mass of 1 magnesium and 2 chlorines together, and you should get a molar mass of 95.21 grams per mole. The volume is 100 milliliters, and of course the concentration we don't know. So we've actually looked at solving problems like this, and hopefully you kept up with the practice or done the practice of the concentration stuff in order to solve. So we are going to find concentration. Remember, that is a two-step process when we're given mass, right? So 1 number of moles just equal to mass over molar mass. We got our 25 grams divided by our 95.21 grams per mole, and we're left with 0.26257746 moles. In step 2, concentration is equal to N over V. We take our 0.26257746 moles and divide it by 0.100 liters, and we get 2.625776 moles per liter. Remember, this is for our MgCl2. Now we needed to do all this so we can set it up to do basically our concentration of ion steps. So I know this is a lot of work just for one question, but it's kind of what we need to do in order to solve these particular types of things here. So now that we have the concentration of magnesium chloride, like I said, we can only use that concentration of ion steps if we have a concentration. So now we can start by solving. And this is when we go 2.625776 moles per liter of MgCl2. Our conversion factor, like so, we want to get rid of MgCl2. So when we look in front, the molar coefficient is 1, so 1 MgCl2 on the bottom. And for our magnesium, we also have a coefficient of 1 Mg plus. So our magnesium chlorides, those units will cancel out. The only unit we're left with is magnesium. So in the one step here, I'm going to solve it and, of course, round with correct number of significant digits, which is going to be 2. And we get 2.6 moles per liter of magnesium chloride. And our next one, or our last one, we're going to do our chloride. We're going to do the exact same thing. In this case, now the coefficient for chlorine is 2. And same thing, I'm just going to solve and round at the exact same time to 2 significant digits because of that 25 grams is not 25.0, just 25 grams. And we should be left with 5.3 moles per liter with rounding. So of course these here, definitely a little more challenging just because there's so much there. But in the end, as long as you can work towards getting a concentration and just realizing that this concentration of ion step is just one extra thing that we need to do once we're given a concentration. Now, this is working forward when we have a mass and then asked to find the concentration of the ion. Now, step 3, or example 3, what we have right here is what mass of magnesium bromide must be dissolved to make a 1.5 liter solution of a bromide ion concentration of 0.3 moles per liter. So this one here is a little different where we have the concentration of the ion and we're working backwards to find mass, which we can still do because we know the formula for mass. Mass is just equal to number of moles times molar mass. So if we can start working our way backwards, we should be able to solve the question. Now, of course, starting off, we will need to have our balanced dissociation equation for magnesium bromide, right? Remember, we are going to have to drop and swap magnesium and bromine, but what you should get, Mg Br2. That is the formula for magnesium bromide. It's aqueous. We have our arrow. We're going to produce the magnesium ion, then plus our bromine ion, and we need to balance it by doing that. Now, because we're given this, we have starting off 0.30 moles per liter of Br minus. Now, if we're asked to find the mass of magnesium bromide, we need to know the concentration of magnesium bromide. We can't use the concentration of the bromide ion. So our first step is going to be, we're going to get rid of our bromide ion concentration and find the concentration of magnesium bromide. So what we have right here, the coefficient from the bromide ion is 2, the coefficient from magnesium bromide is 1. So when we do this, we get 0.15 moles per liter of MgBr2. Now this is exactly what we needed, because now that we have the concentration of magnesium bromide, now we can find the number of moles of magnesium bromide by going C times V, and we have that concentration, and the volume is 1.50 liters. So now we have 0.30 moles. Oh, sorry, that is not the answer to that one, sorry. It's not 0.30, it is actually 0.225 moles. Sorry, I accidentally put that into my calculator wrong for a second. Now finally, mass of magnesium bromide is equal to number of moles times our molar mass. So 0.225 moles times the molar mass of magnesium bromide. So just remember, back to your periodic table, we have magnesium, we have bromide this time, so we got 1 magnesium and 2 bromines. We add those molar masses together and we get 184.11 grams per mole, and we get our answer of 1.4 grams. And that is our answer with, of course, oh, sorry, I have to round that because that is only this is 3 significant digits. My answer needs to be in 2 significant digits. So I'm going to take this answer, I'm going to erase it like this, and put in my correct one of 41 grams. And that is my 2 significant digits right there. All right, and that is, of course, how we solve for concentration of ion. So either starting with a mass, finding the concentration of the ion, or starting with the ion and then going back and finding the mass. So really, so far, the maximum amount of steps that you have done in one equation was 2 steps. Now, as you can tell, we've moved up to a 3-step style calculation. So it all comes down to what information you're given. But of course, getting lots of practice at this will definitely benefit you. So we'll notice that we have concentration of ions in solution practice. So this is for you guys to practice on your own. Once again, the answer key I already have posted up on Google Classroom, so you can work through these here, check your answers. And same thing, if you're not sure on any of these here, you can either email me or save your questions until we have our Google Meet on Thursdays. So anyway, good luck. Make sure to get plenty of practice with this, and I'll see you guys for the next lesson, which is on preparations of solutions.